Next, what about mean of discrete random variable? Okay, what is mean of discrete random variable? When we say mean of a random variable with a discrete probability distribution is mu is equal to the summation of your random variable, okay? The summation of your the summation of the product of your random variable and its corresponding probability. Okay? The summation of the product of your random variable and its corresponding probability. Okay? So where x of 1, x of 2, x of 3 up to x of n are the outcomes, and then the probability of x of 1 up to the probability of x of n are the corresponding probabilities. Take note, the summation of your random variables multiplied by its corresponding probabilities means to sum the products. Okay? Means to sum the products. So what do you mean by that one? So for example, find the mean of the number of spots that appear when a die is tossed. Find the mean of the number of spots that appear when a die is tossed. So this is your probability mass function using table. So the outcome, when we say outcome, you're referring to the number of spots that appear when die is tossed. Okay? X there, yung capital X, you're referring to the number of spots that appear when a die is tossed. So what are those values? Of course, 1 to 6. Why is it up to 1 to 6? Why is it up to 1 to 6? Because we only have 6 faces. And what are those? Number 1, number 2, number 3, up to 6 faces. Okay? A die composed of 6 faces. Next, what is the probability? Okay? So what is the probability of getting 1? That would be 1 over 6. Why is it? Bakit naging 1 out of 6? Because, why is it 1 out of 6? Because there is only 1 face out of 6 faces in a die. So the probability of getting 1, okay, is 1 over 6. And then the probability of getting 2 is 1 over 6 also, up to 6. Okay? So the probability of each value is 1 over 6. Now to solve for the mean, so how do we solve for the mean? Get the product of each and then you add. Okay? So 1 multiplied by 1 over 6 plus 2 multiplied by 1 over 6 plus 3 multiplied by 1 over 6 plus 4 multiplied by 1 over 6 plus 5 multiplied by 1 over 6 plus 6 multiplied by 1 over 6. Then your mean is 3.5. 3.5. So that's the mean. Okay? Next. The probability distribution is given below. I repeat, for the second problem. In a family with 2 children, find the mean number of children who will be girls. The probability distribution is given below. Okay. So number of girls, 0, 1, 2, and its probability will be 1 over 4, 1 half, and 1/4. The question is, Miss, why is it 0 up to 2 only? Why is it the number of girls is 0 up to 2? What's the reason behind that? Can anyone give me the reason? Why is it only up to 2? Because?
There are only 2 children.
Okay, very good. Because we're talking about 2 children. Okay, we're talking about 2 children. 0 because, why is the first value 0? Meaning?
There's a possibility that there are no girls.
Okay, 1. The second value is 1. Why is it?
There could only be like 1 girl.
Okay, very good. Next. Then the last is 2. Meaning, okay, very good. Next, what is the probability of getting 0? The answer is 1/4. Why is it 1/4? Why is it 1/4? How do you get 1/4? What are the possible outcomes of a family with 2 children? Can you give me the outcomes? It can be girl, girl. What else? Girl, boy. Boy, girl. And then the last is boy. Okay, so how many outcomes do we have?
4.
4. Now, what is the probability of getting 0? Meaning there's no girl at all. All of them are boys.
1.
1 out of
4.
4. Okay, next. What about the value is 1? One of them are girl. The answer is 1/2. Why is it 1/2? Why is it 1/2?
Yes, because it would be 2 over 4. The first child may be the girl, or the second child may be the girl.
Okay, so there are 2 out of 4, which is? What is? Okay, 1/2. Very good. Next. If the value is 2, then the probability is 1/4, meaning Meaning what? How do you get 1/4? 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 Meaning? Meaning what? There are only... Yes, my dear. Continue, yes. There are only what? There are only one possibility out of 4 outcomes that the 2 children are all girls. So the probability of getting 2 girls of the 2 children is 1/4. Now, how to solve for the mean? So to find the mean, multiply the number of girls to its corresponding probability and then you add. Okay, so that will become 0 multiplied by 1/4 plus 1 multiplied by 1/2 plus 2 multiplied by 1/4. So the answer is 1. So the mean is 1. Okay, next. What about variance? Okay, so variance of a probability distribution is found by multiplying the square of each outcome and its corresponding probability and summing this product and subtracting the square of the mean. So to solve for the variance, so the variance of probability distribution is found by multiplying the square of each outcome by its corresponding probability and summing this product and subtracting the square of the mean. Miss, what do you mean by that one? Okay, for example, the standard deviation of the probability distribution is the square root of your variance. Okay, before we proceed to the example, take note that the standard deviation of the probability distribution is given by the square root of your variance. Okay? So leptokurtic, mesokurtic, platykurtic, leptokurtic, when we say kurtosis, you are referring to the thickness of the distribution. Okay, most of the distribution is in the upper, so that's leptokurtic. If the distribution is most on the lower, that is platykurtic. But if it's a normal distribution, we call it mesokurtic. Okay, just to give you additional information. Okay, so why do we need to study kurtosis? We need to study kurtosis if you want to determine the prediction of the sales. Okay, so if the sales is located on the upper, so meaning you can predict if the next sale of the month can be the same or it will become low. Okay, but if it's a platykurtic, it's unpredictable. Kapag platykurtic, unpredictable. You don't know it will be increased or not. Okay, but if it's leptokurtic, so more or less you can predict na pwede siyang mag-decrease or pwede rin siyang mag-increase. Okay, but if the distribution is platykurtic, it's unpredictable. Okay, so that's the application of kurtosis. When we say kurtosis, you're referring to the thickness of the distribution. Okay, so let's proceed now. Variance of probability distribution. Example number 1. The probability that 0, 1, 2, and 3 or 4 people will be placed on hold when they call a radio talk show with 4 phone lines. It's shown in the distribution below. Find the variance and the standard deviation. Okay, so we need to look for the variance and the standard deviation. So x, when we say x, you're referring to the number of people. Okay, they call a radio talk show. Okay, so we have 0, 1, 2, 3, 4. And then probability of your random variable, that will be 0.18. Okay, if the value is 0, the probability is 0.18. If the value is 1, the probability is 0.34. If the value is 2, the probability is 0.23, and then so on and so forth. The question is, how do we solve for the variance and standard deviation? So to solve for the variance, okay, to solve for the variance, first you need to solve for the mean. How do we solve for the mean? 0 multiplied by 0.18 plus 1 multiplied by 0.34, okay, plus 2 multiplied by 0.23 plus 3 multiplied by 0.21 plus 4 multiplied by 0.04 is equal to 1.59. So that's the mean. Now, so solve for the variance. How do we solve for the variance? Get the square of the value. Okay, what do you mean by that? 0 raised to 2 multiplied by its corresponding probability. So 0 raised to 2 multiplied by 0.18 plus 1 raised to 2 multiplied by 0.34 plus 2 raised to 2 multiplied by 0.23 plus 3 raised to 2 multiplied by 0.21 plus 4 raised to 2 multiplied by 0.04, that will be equal to 3.79. Now, to solve for the variance, 3.79 minus your mean squared, so that will be 1.59 squared. Okay, so 3.79 minus the square of your mean, which is 1.59 raised to 2, your variance will be 1.26. Now, to solve for the standard deviation, how do you solve for the standard deviation? How do you solve for the standard deviation? How do you solve for the standard deviation? How do we determine the standard deviation, people? Hello? Are you still there?
Square of the variance.
Okay, square of the variance. So what's the square root of the variance? What's the square root of the variance? What's the square root of 126?
1.12.
Okay, 1.12. So to solve for the standard deviation, just simply get the square root of your variance. Okay? Okay, let's proceed now. Next, number 2. So we will continue our discussion for mean and variance of a probability distribution. Okay? We're in example number 2. Consider 4 tosses of a fair coin. Construct a probability distribution for the number of tails. Find the mean, find the variance, and then the standard deviation. So how do we do that? How do we do that? How do we solve number 2? Consider 4 tosses of fair coin, construct a probability distribution for a number of tails, find the mean, variance, and standard deviation. So first and foremost, we need to do the tree diagram. Okay? Tree diagram. So we have the first coin. So we have head and tail. So this will be your first coin, second, third, and then fourth tosses of coin. Okay, so we need to determine the number of outcomes before we construct a probability distribution. Okay, probability distribution can be in the form of table, graph, or formula. Okay, so first we need to identify the outcomes of the number of tails. Okay, consider you need to have a 4 tosses of fair coin. Okay, so this is your first coin, second, third, and fourth. Let's say the first coin is head, and then for the second coin, it can be head or tail. And then the third coin, it can be head, tail. And then the fourth, something like that, head and tail also. Okay, then repeat the process. So we have head, tail. So same thing, so we have head, tail, head, tail, head, tail. Okay, so again, before we construct a probability distribution, first, you need to determine the possible outcomes. And how do we do that? Of course, we need to use the tree diagram. Okay, next, if the first coin is tail, so what will be your second coin? So your second coin, it can be head or tail. Head, tail for the third coin. Okay, head, tail. And then we have head, tail. Head, tail. Head, tail. And then we have head, tail. Now, so after we construct a tree diagram, okay, tree diagram, you can now identify the possible outcomes. So what are those? Can you give me the possible outcomes? What will be the first? What will be the first outcome? Based on the illustration that we have, what are the possible outcomes? What are the possible outcomes? Okay, so we have head, 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 head. Okay, and then we have head, 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 tail. And then we have head, head, tail, head, 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 tail, tail. Okay, next. So we have head, tail, head, 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 tail, head, tail. And then we have head, tail, tail, head. And then we have head, tail, tail, tail. Okay, next. What if the first coin is a tail? So we have tail, head, head, head. And then we have tail, head, head, tail. And then we have tail, head, tail, head. And then we have tail, head, tail, tail. Okay, next. So we have tail, tail, head, head, tail, tail, head, tail, 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 head, and then 4 tails. Okay, so these are the outcomes. So how many outcomes do we have? How many? How many outcomes do we have? How many outcomes do we have? 4, 4, 4, 4. So how many outcomes do we have? How many?
16.
Okay, 16. Okay, so 16. So after we construct a tree diagram, we can now construct a probability distribution using the table form. Okay, using the table form. So let's construct a probability distribution using a table form. Okay. First will be the number of tails, and then the second will be the probability of getting those tails. Okay. So first will be the number of tails. So what will be the value of the number of tails? What will be the value? So first column, x pertaining to the number of tails. And then we have the probability of the number of tails. Now, what are the possible value of the number of tails? Ano yung mga possible value? What are the possible values of the number of tails? It can be what? Ano yung mga value? How do we represent that in terms of value? Can we say it should be 0 to 4? The number of tails can be 0 to 4. Can we say that? Why is it 0? Why is it the first value is 0? Why is it the first value is 0? Why is it? What do you mean by that? Meaning, okay, meaning after you toss a coin 4 times, okay, the outcome are all heads. So meaning there's no tail. So the first value is 0. Next, what about the second value? What about the second value? What about the second value?
1.
Okay, 1. Next. Next value.
2.
Okay, 2. 3, and then 4. Why is it up to 4 only? Why is it up to 4? Because, okay, very good. Because we only have 4 tosses of coin, okay? So we need to toss a coin 4 times. So the value is up to 4. Now, next is the probability of getting those values. So what is the probability of getting 0? Based on the tree diagram that we have, what is the probability of getting 0? Meaning, what is the probability that the outcomes are all heads? It's not tails. So what would be the probability?
1/16.
Okay, 1/16. Very good. Next. What is the probability of getting 1 tail only after we toss the coins 4 times? What is the probability of getting a tail, 1 tail only, after we toss a coins after we toss a coin 4 times? Okay. So using the tree diagram, so we have 1, 2, 3, 4. There should be 1 tail. So it should be what? How many? How many?
4/16.
Okay, 4/16. What is 4/16?
1/4.
Okay, 1/4. Next. What about 2 tails? After we toss a coin 4 times, okay? What is the probability of getting 2 tails? 2 tails. 2 tails. 1, 2, 3, 4, 5, 6. Am I right? Is it 6?
Yes,
And double check. So we have 6/16. Next. What's next? What's next? What is the probability of getting 3 tails? 3 tails. 3 tails. 1, 2, 3, 4. Is it 4? Can you please double check? Can you please double check? Okay, 4. 4/16. So what is 4/16?
1/4.
Okay, 1/4. Next.
That's no problem. The probability is different.
Which is? What is 6?
3/8 po.
Okay, 3/8. 3/8. Okay, next. What about 4?
1/16.
Okay, 1/16. Okay, so we have 1/16. Okay, so 1/16. Okay, now, so we're done with the construction of probability distribution. Find the mean. So how do we solve for the mean? 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 Solve for the mean is get the product of the value and its corresponding probability. Okay, the summation of the product of its value and its corresponding probability. So that will be 0 multiplied by 1/6 plus 1 multiplied by 1/4 plus 2 multiplied by 3/8 plus 3 multiplied by 1/4 plus 4 multiplied by 1/16. So can you please give me now the mean? So what will be the mean? 0 multiplied by 1/6 plus 1 multiplied by 1/4 plus 2 multiplied by 3/8 plus 3 multiplied by 1/4 plus 4 multiplied by 1/16. So can you please give me now the mean? What's the mean? Using your calculators, what's the mean? What's the mean, my dear people? What's the answer? Just get the product and then add everything. What will be the answer? Anyone? Can you please give me the answer?
2.
The answer is 2. Let's check. So we have 1 over 6 plus 1 multiplied by 1 multiplied by 1 over 4 plus 2 multiplied by 3/8. Let's check. Plus 3 multiplied by 1/4 plus 4 multiplied by 1 over 16. Okay, so the answer is 2. That's correct. So we have 2. Okay, very good. That's 2. Now, next, what about variance? Okay, what about variance? So to solve for the variance, okay, to solve for the variance, so this is the symbol for the variance. So to solve for the variance, that will be the summation of the square of the value, okay, multiplied by this corresponding probability minus the mean squared. Okay, so to solve for the variance, summation of the product of the square of the value and its corresponding probability minus the mean squared. So what do you mean by that one? That will become 0 squared multiplied by 1 over 16 plus 1 squared multiplied by 1/4 plus 2 squared multiplied by 3/8 plus 3 squared multiplied by 1/4 plus 4 squared multiplied by 1 over 16. Okay. So after you get the summation, you need to subtract it by your mean. What is the mean a while ago? What's the value of the mean? What's the value of the mean a while ago?
2 po.
Okay, 2. So you need to subtract it to the square of the mean. So that will become 2 raised to 2. So therefore, what is your variance? Okay. What will be your variance? Can you see it? Can you see the whiteboard? The solution in the whiteboard, can you see it? Can you see it? Okay. Can you please give me the answer? Zero squared multiplied by 1 over 16 plus 1 squared multiplied by 1/4 plus 2 squared multiplied by 3/8 plus 3 squared multiplied by 1/4 plus 4 squared multiplied by 1 over 16 minus 2 raised to 2. Okay, minus 2 raised to 2. So what will be your variance? So what will be your variance? Times 1 over 16 plus... Yes, anyone? What will be the answer? Can anyone give me the answer? Meron na?
3 minutes.
What's your answer?
3 po.
3? Okay, let's check. Plus 4 squared multiplied by 1 over 16. Okay, let's see. Okay, 5 minus 5 2 raised to 2. What is 2 raised to 2? We need to square the mean. So that will be 2 raised to 2. So what will be the answer now? You need to square the mean. Okay, 1. So your variance is 1. Now, what about the standard deviation? How do we solve for the standard deviation? How do we solve for the standard deviation? To solve for the standard deviation, that will be the square root of your variance. Okay? So the square root of your variance. So therefore, what is the square root of your variance? To solve for the standard deviation, just simply get the square root of 1. So what will be the square root of 1?
1.
Okay, 1. Okay, so that's how we solve for the mean, variance, and standard deviation. Okay, next example, number 3. A certain industrial process is brought down for a recalibration whenever the equality of the items produced falls below the specifications. Let X represent, okay, when we say capital X, you're referring to the random variable, okay? Let X represent the number of times that the process is recalibrated during a week. And assume that the random variable X has the following probability mass function. Okay? So in constructing a probability mass function, the problem use tabular form or the table form. So find the mean and variance of the given example. So how do we solve for the mean? Can anyone? How do we solve for the mean? How do we solve for the mean of the given example? How do we solve? Mean. How do we solve for the mean? Mean is equal to what? Mean is equal to what? Anyone? How do you solve for the mean? You just simply what? Multiply. Anybody? How to solve for the mean? How to solve for the mean? Anyone? Anyone? How to solve for the mean? Can you still hear me? Hello, people? Hello? Can you still hear me? Can you still hear me? How do we solve for the mean? So to solve for the mean, just get the product and then add everything. So that will become 0 multiplied by 0.35 plus 1 multiplied by 0.25 plus 2 multiplied by 0.20 plus 3 multiplied by 0.15 plus 4 multiplied by 0.05. Now, so what is your mean? What is the mean based on this? What is the mean? Just get the product and add. So what's the mean? 0 multiplied by 0.35 plus 1 multiplied by 0.25 plus 2 multiplied by 0.20 plus 3 multiplied by 0.15 plus 4 multiplied by 0.05. So what will be the answer? What will be the answer? Anyone?
30 over 10 or 1.3?
Okay, 1.3. Now, next, what about the variance? How do you solve for the variance? To solve for the variance, just simply square your values. That will become 0 squared multiplied by 0.35 plus 1 squared multiplied by 0.25 plus 2 squared multiplied by 0.20 plus 3 squared multiplied by 0.15 plus 4 squared multiplied by 0.05, and then subtract it by your mean. Okay? Subtract it by your mean squared. Okay? Subtract it by your mean squared. Now, what will be the answer? So the answer for that, what will be the answer? What is your mean a while ago? What's the mean? What's the value of the mean a while ago?
1.3 po.
1.3. So 1.3. Now, what about your variance? Okay, minus the mean squared. So what will be your variance? If your mean is 1.3, what about your variance? So 0 squared multiplied by 0.35 plus 1 squared multiplied by 0.25 plus 2 squared multiplied by 0.20 plus 3 squared multiplied by 0.15 plus 4 squared multiplied by 0.05 minus your mean squared. Okay, so that will become minus 1.3 squared. So therefore, what is your variance? So what will be your variance? Use a calculator. Okay, use a calculator to compute for it. Okay. So we have 0 squared multiplied by 0.35 plus 1 squared multiplied by 0.25 plus 2 squared.
Is it 1.51?
1.51. Okay, let's check. Plus, you already subtracted by 1.3?
Yes, yes.
Let's check. Okay, so we have plus 3 squared multiplied by 0.15 plus 4 squared multiplied by 0.05. Okay. Minus 1.3 squared. Okay, 1.51. That's very good. So we have 1.51. Okay, so 1.51. So that will be your variance. Next, number 4. The probabilities of machine manufacturing 0, 1, 2, 3, 4, 5 defective parts in one day are 0.75, 0.17, 0.04, 0.025, 0.1, and 0.005. Okay, construct a probability distribution for the data, find the mean, find the variance, and then find the standard deviation. So how do we answer number 4? How do we answer number 4? First, we need to construct a probability distribution table. Okay? Construct a probability distribution using tabular form or table form. So how do we do that? So table. Okay? So we have X pertaining to the number of defective, okay, defectives. And then the other one is the probability of getting those defectives. Okay? So what are the number of defectives, defective parts? What will be the value? What will be the value of your X in that particular problem? What are those values? Okay, very good. So we have 0, 1, 2, 3, 4, 5. Okay? So these are the values. Okay, next, what about its probability? What is the probability of getting 0? Based on the problem. What's the probability of getting 0?
0.75.
Okay, 0.75. Very good. Next, what is the probability of getting 1?
0.7.
Okay, 0.17. Next, probability of getting 2. Okay, 0.04. Next. So we have 0.025. Next, 0.01. Next, 0.005. Okay, now, find the mean, variance, and then standard deviation. Okay, find the mean, variance, and then standard deviation. So what will be your mean? So what will be your mean?
0.39.
Okay, 0.39. 0.39. Next, what about the standard what about the variance? What about the variance? How do we solve for the variance? How do we solve for the variance? Square and then multiply, and then you add, and then subtract it to your mean, the square of your mean. So what will be your variance? So what will be your variance? What will be your variance? Variance, variance. What will be the variance? Anyone? What's the variance? The variance is? Get the product. So that will be 0 squared multiplied by 0.75 plus 1 squared multiplied by 0.17 plus 2 squared multiplied by 0.04 plus 3 squared multiplied by 0.025 plus 4 squared multiplied by 0.01 plus 5 squared multiplied by 0.005. Okay, and then subtract it by your mean. Okay, the square of your mean, so that will be 0.39 squared. So therefore, what is your variance? What's the variance? Just use a calculator to answer this one. So what will be the answer? Yes, yes. What's the question?
0.6879.
Okay, so that will be your variance. 0.6879. Okay. Now, next, what about the standard deviation? What is your standard deviation? The standard deviation is the square root of your variance. So the square root of 0.6879. So what will be your standard deviation? What is the standard deviation? What's the standard deviation?
Ilan po yung random?
2 decimal places.
0.83 po.
Okay, 0.83. 0.83. Okay? Question, is it clear, people? Is it clear?
Yes, yes.
Okay, next, number 5. So survey of families in neighborhood A. Y is the number of children in the family. Okay. So to solve for the mean, yan. So same thing like that. So children, the family, so that will be 0, 1, 2, 3, 4. Frequency 81, 43, 14, 0, 1, 2. And then the probability are the following. Okay. So the probability of getting 0, that will be 0.5827. The probability of getting 1 child, that will be 0.3094. The probability of getting 2 children, that will be 0.1007. And then so on and so forth. Okay. So that's it. So to solve for the mean, get the product of its value and its corresponding probability. Okay, so same thing lang. To solve for the standard deviation, get the square root of your variance. Okay, next, what about number 6 example? Let x be a discrete random variable mass function given by the table below. Okay, find the probability of 0. So find the probability of 0. Find the probability. What's the answer?
2 over 7.
2 over? What's the answer? What's the answer, my dear?
3 over 7.
Okay, how do you get 3 over 7?
Yes, pinag-add ko po yung grade and then pinag-block ko na 1.
Okay, why is it we need to subtract it by 1? Because?
Yes, because 1 is the, parang,
Total.
po.
Okay, the total probability is 1. So to determine the probability of the value which is 0, okay, so you just subtract it by 1. So the answer is 3 over? Okay, 3 over 7. Next, what about the mean? So if 0 is 3 over 7, what about the mean? How do you solve for the mean? If the probability of 0 is 3 over 7, how do you solve for the mean? How do you solve for the mean? How do you solve for the mean? Multiply the value and its corresponding probability. Okay? So multiply its value and its corresponding probability. Okay? So that the value of 0 is 3 over 7. And for the mean, that is 1. Okay? Variance, okay, 2.5714. And then how do we solve for the standard deviation? How do we solve for the standard deviation?
Square root po.
Okay, so what's the square root of 2.5714? What's the square root? What's the square root of 2.5714? So the square root is 1.6. Okay, 1.60. So we need to, your answer must be in 2 decimal places. So 1.60. Okay, so 1.60. So that will be the standard deviation. And then for the graph, for the histogram, this one, the number in the horizontal line, that will be the values. Okay, and then the number in the vertical, that will be your corresponding probability. Okay, so the number in the horizontal, that will be the values, okay, the value of x, and then the vertical line naman, okay, in the vertical aspect, that will be the probabilities, the corresponding probabilities of each value. Okay, so that is how we solve, okay, or how do we determine the mean, variance, and standard deviation of a probability distribution. Okay,